points in there, and then move on to what is CI, what is continuous testing, what does it look like in your environment, how can that be built out using some tools and connections and integrations with different tool sets. So thanks, Jimmy. So let's begin the meat of the webinar. So the whole push to CI and DevOps in general is really driven by the market. You know, you and I are in the marketplace. We are customers as well as working on developing applications. So as a customer, you know how impatient we've become with applications, particularly in the mobile sphere. There's a lot of demand for very, very fast applications. You know, I don't use it too much on my phone, but my kids, oh my goodness, that's what they, tablets and phones, they're constantly on some application doing something. So the expectation has been driven really high for what the customer expects as far as functionality, features, as far as performance, as far as security, for sure. We hear all the time about security breaches on the news. That's something nobody wants to be in the news for. So that demand has really dictated a move to a faster form of developing applications. God forbid you're in the gaming world developing games. There's nothing more critical than that, to have a strong application, a fast application. So, and we've kind of on the developer side, we have to keep track or keep up with our with those who are our competitors. I'm sorry, that's what I'm thinking of. So we have competitors. We're constantly keeping up with. That just drives the demand heavier and heavier, not just customer demands, but also keeping up with our people we're competing against as well. All right. So every business is a software business. I don't care what your company does, but in the heart of your business, software runs the back end of your business. So our customers can be internal, not just outside customers, but our customers can be internal as well. So maybe you're developing a new application to replace some old a green screen application. There's a lot of demand around that as well. All right, it has to be timely, has to be accurate, has to be fast, and has to be secure. So again, your business, no matter what you do, you are in the business of developing and testing and delivering software. So we've all seen this graph before. The idea is the faster you create applications, the higher risk you have of having security problems, having functional issues. There's a higher risk. The faster you do anything, the higher risk you have. So the idea in this graph is to move that intersection between software quality and risk to the left while maintaining a low risk. Okay, high velocity, low risk. We've all seen in the waterfall environment that's virtually impossible to do. So Agile has been developed to kind of face that challenge, resolve that challenge, but there are shortcomings in the simple Agile methodology as well. So DevOps and continuous integration and testing is a way to kind of fill those gaps in, even for the Agile process. All right. So let's look at how we can move this intersection to the left. But first of all, let's take a look at our current process. For those of you who have, I imagine just about everybody in the QA world today has been on a project, a waterfall methodology project. So this is a linear process. And there are some loops we could build in here, internal loops, but overall it's a linear process. So the business comes to the organization and says, we have an idea for a product. We think this will work, it'll sell, or we need it internally. They go to a bunch of BAs, they start planning, developing requirements. In the meantime, developers are working on some other project. They really can't get started until they have a set of requirements. Start developing the code against the requirements. Testers are sitting there waiting for the code drop or deployment to actually be able to test those requirements. In the meantime, they're developing tests. But the whole idea here, all these parts are siloed. One part can't start before the other phase is completed. All right. So during testing, a lot of it, even still, we run across many, many organizations that have zero automation in-house. Everything's a very manual process. There's only so much time in a day and so many people in the organization that can be dedicated to testing the application. We've seen many times where organizations will bring in BAs for a week or two at a time to test, or the end user will have to come in and fill the gap of the manual testing if there's no automation in place. That just drags out the time frame. And then at the end, you have a lot of defects. So what do you do with these defects? You send them back to development. Okay, typically the first cycle, you're not going to have anything that really can be released. It's going to be sent back to the development team. And this cycle repeats itself until at some point you come across the date that you've set. So, okay, we need to make a decision. Do we release or don't we release? And a lot of times organizations will just hold their nose, cross their fingers, and say a prayer and release the product. Sometimes there's really no clue what's going to happen at the end. They're not sure how, if the requirements are fully tested. Maybe that integration isn't set up a good management tool where requirements are connected with tests. So they really don't know what the coverage. So very easily something could be missed. It depends on how critical that piece is that was missed. And this response can come from the end user in a mobile environment. The end user will respond very, very quickly if there's an issue with the application. You'll get a score very fast online as far as what they feel, how they think about your application. All right. So in the end, the whole process here is a very manual process. Very prone to errors. One handoff to another via meetings or emails or whatever it happens to be. Dates set, hard dates that can't be moved. So okay, we'll deliver this, but the quality isn't that great. But let's deliver it and we'll test it and see what happens. And I'll give an example. Recently, we had a customer who had us engage them for a 3 or 4 week load runner engagement. So the idea was to performance test this application and load test the application. The application has yet to go live after being in development for 3 long, painful years. And they were up against, I don't know how many times the date's been pushed out, but they were up against another date. And the last thing to do with this application is performance testing. It was very evident very quickly within the first 3 or 4 days that there's some major, major issues with this application. And the engagement was cut short because, well, they were saying there's no way to really fix these quickly to come back in and retest them. We're going to have some major rework. We'll get back to you. So there's an example, and a poor one, of an application that's gone through this linear cycle and after 3 years still has no product to show. All right, hopefully your organization is not in that situation. I hope you're not raising your hand right now and nodding, saying, yeah, that feels familiar, because it's a painful process. So the idea is to take this model and move it into a cyclical model where you're using better tools, better processes, better integrations with tools, better communication with your team, and you eliminate these silos. All right. So rapid development reveals constraints. So those constraints we just talked about. The faster you try to develop an application, the more those constraints become painful. You can only do so much with constraints. You only have so many resources to produce so much outcome. So those constraints can be, you can try to make them tight, but you'll pay the price in the end. All right. So the key to proper CI implementation is to remove those constraints, and you do that via tools and processes, which we'll get into. One of the keys to implementing CI is to increase automation. Essentially, automate everything. That's the mantra. With continuous integration, continuous testing is automate everything. There's a lot of routine tasks that are involved in deploying code, creating builds, testing, okay? A lot of routine tasks that tools now can take on for themselves. And the idea is tools don't go on vacation. They don't get sick and call out. So if you're relying on an individual for a manual task and they can't be in the office for some reason, your process can be on hold if there's no one else to fill those shoes. However, if that process was automated and scheduled, then it doesn't matter who's there, who's not there. That process will be executed, and the results will come out in the end, and then the next process can pick up the testing or whatever happens to be. All right. This ensures repeatability and reliability of these tasks, and in the end, it reduces errors. Anything that's mundane, common, kind of a boring task that humans, that we have to develop or do over and over again, it can become boring. Boring creates sloppiness, and with sloppiness, you get errors. I mean, that's just who we are, and I'll raise my hand to that. It happens to everybody, right? Machines don't care. They'll do what they're told to do when they're told to do it. We just make sure to tell them to do the right thing. All right, so it kind of eases up on the errors and increases repeatability for the automation. So when it comes to latency, excuse me, what you want to do is, again, automate everything. The builds can be scheduled on a daily basis, every other day, whatever your organization decides. So those builds are ready on a regular basis. The testing team knows when they're ready. And besides that, included in those builds can be tests that are triggered automatically as well. And Jimmy will get into that later as we get into the presentation. But some areas of testing you want to make sure you're taking advantage. If you're not, you can just get you started in this matter. Is API testing is critical to what's called shift left testing. So how early in the life cycle is your organization testing the application? API testing can begin before there's a GUI involved in the application. And there's a number of tools to do that. We won't get into that, but it's a critical piece. The other part that's important is automated unit testing. There are tools that are out there. Selenium is one of them. HP's, excuse me, LeanFT is another that embed themselves in the developer's API, or the developers can create automated tests that, upon creating the build, will actually test that code immediately. So you know right away whether things are working or not before it goes off into regression testing. Test virtualization is another part of testing that allows you to test earlier, especially when it comes to processes that you're testing that may not be available for whatever reason. So you may be relying on a third-party process that integrates into your application that may not be ready. You can virtualize that using a number of tools on the market. HP has what's called service virtualization. But you can actually replicate those services, include them in the build, so when you test, and another example is like pinging Visa or MasterCard or American Express for an online purchase. Your testing can ping that virtual service, and it behaves the same way that Visa will behave, accepting or declining a card or whatever it happens to be. All right, so those are important pieces. The other part that's important is security testing throughout the process. There are a number of tools available for security testing your application. HP has, excuse me, a number of tools for static, or a tool for static testing your code. Okay, so it's called Fortify or Fortify on Demand. Another tool called Web Inspect that is a dynamic testing tool where it actually walks through your application from the GUI perspective and tries to get inside, create security breaches in your application from a user's perspective. And there are a number of other tools on the market as well. So make sure you include these pieces in your testing. Don't wait for security testing until the end, like that company did for load testing, because if you find a serious breach, it could take some time to actually wrap back around again, get that security plugged, and then retest everything again. So those are some of the important pieces. Monitor and measure everything. Everything in a CI environment needs to be visible to all the stakeholders. So again, we're taking down silos. So reporting and metrics are shared between all the different teams. All right, and the tools that are developed for this that Jimmy will talk about more have internal monitoring and measurements built in that can be reported on. And this provides feedback. So data is important. What you do with that data is even more important. Okay, use it to create feedback so that your next cycle is faster or more productive or more accurate, whatever measurements you want to utilize. So the idea is to take the data, improve on your process so the next iteration is more robust. Okay, visibility across the teams. We'll never do away with meetings. Sorry, but you always have meetings on a regular basis. But the information provided in a CI environment is enormously valuable and fills the gap between those meetings. So the idea is replace what's in the background there, that linear process we talked about. Let's take all those pieces, move it to a cyclical process, and create a continuous integration and testing environment. And wrapped around that is continuous assessment. So assessing your process, reporting back, and getting better feedback, and that will help your organization produce more robust applications faster.
So, I'm gonna start from here, Dean, and kind of take over and kind of go through with this process and what we're going to do, and kind of discuss some of the tools and how the environment is laid out, and just kind of move forward that way. So we're looking at this slide here, and you start to look at what we're seeing. Well, all of the slides leading up to this and all of the discussion that Dean had is was bringing us to this, and that, in these three inner circles, continuous integration and testing, the continuous delivery, the continuous operations, are all kind of relating back to, kind of the points that Dean was making. And that obviously, though, it's, wrapped with this continuous assessment. What we're going to focus on is the first circle, and that is the continuous integration and testing. From that standpoint, when we're looking at this overall environment from a QA standpoint, we're getting involved in continuous integration. Some of the most important things are to start to understand and to start to build out this CI or CT type of infrastructure and processes in place so that you can take advantage of that. When we look at these circles, they're all very important, and they have to be there to get to the whole high velocity innovation kind of model that we've discussed. But really the beginning part of that and the start of it is the continuous integration and testing. So when we start looking at that, when we talk about building your process, your CI process, or assembling the parts to add horsepower, one of the themes of this, of this webinar in general was kind of a car theme and speed and showing that adding some parts and pieces to a process or things that you already have in place can make that not only better and faster, like a muscle car maybe or a dragster, but really start to improve that testing process that you might and that you have in place already, and or adding in additional components to that to really broaden that out and make it very robust. So when we speak to that, a lot of what we're talking about here as part of the takeaway was, well, how does ALM fit into that environment, and what can it do? What tools can ALM connect into? And so when we look at ALM as an environment, ALM can do a ton of things in a CI or CT environment, and it has a lot of integrations to a lot of third-party tools, open source tools that are out there, other enterprise-level tools. So to be able to take this and to say, looking at different IDEs, when you have the ALM license and you add in and enable ALI, you have the ability to actually, in your IDE for your developer, you can enable a connection directly into ALM, where you can create requirements from the IDE, you can create defects from that IDE, you can be looking at getting tasks assigned to you. All of that stuff comes native to the developer. They don't have to step outside and log into a separate ALM instance to try to get that information that they need. When you talk about build servers, you can configure these build servers inside of ALM to where you have visibility to them, you have reportability on what builds have been completed. When we talk about source code management, CVS and Subversion, Git, you can set those up inside of ALM, and you can control your branches of your code. All of that stuff can be done from inside of ALM itself. And then, all of that ties back together to the big blue circle in the middle, and how ALM handles not only those third-party integrations that we see on the outside of it, but all of the internal HP tools that are integrated with ALM intimately. You look at lab management and service test, Sprinter, Fortify. When we talk about exploratory testing, those are all pieces that are native to being able to connect into ALM and have that integration. Lab management is where you can define different servers and hosts and all of those things so that you can actually execute scripts from they call it a server side execution versus the client side execution in a traditional ALM environment in the test lab module. When we talk about regression, the integration between unified functional testing, adding in that service virtualization piece, and Agile Manager allows you to tie all that in and start to develop, the testing and functional testing that you want for your regressions. And then at the, the overall circle of longevity testing, you're still taking that service virtualization, UFT, now adding in some performance centers. So, when Dean talked about earlier that, that some of these organizations were waiting so far or so long into the development cycle to be able to add that performance testing in, these pieces are already integrated into ALM and can be added in very early on in the SDLC and the testing cycle. Business process testing is, being able to create some modular components that, that allow you to, have your business and other non-technical people to be able to start to assemble tests from those building block type of components. So all of this stuff combines in to give ALM and ALI and all of these HP tools a very robust feature set that can be used for part of this continuous integration and continuous testing. But additionally to that, when you start talking about the overall environment, you don't have to be using, strictly ALM or ALM itself to manage all of that. A lot of these applications, even these ones here with, the third-party tools, will tie into themselves or tie into other pieces. Your source code management, obviously will tie into Hudson and Jenkins and your build servers or continuous integration servers. Automation servers are all, there's multiple names for them now. Your IDEs will tie into source code. All of that stuff is kind of common. And that's what we're saying when we talk about pieces of this puzzle for continuous testing that are already existing in your organization. So as part of continuous integration and continuous development, all of that as a whole, Dean talked about breaking down silos, but that not only, talks about process and just visibility for each other to be able to see what's happening, but it also starts to push that you have some interactions and stuff that are not normal, probably in a traditional waterfall methodology, as far as people using certain tools that were in the past strictly for maybe for development or for like that build, your automated build deployments. Now you have add-ins that actually will tie into ALM and kick off these tests, whether it's UFT or lean FT or whatever you're doing. But those are coming from a build server where traditional QA you wouldn't necessarily even interact with that build server. And the same thing with the actual operations and monitoring. You might have monitors out there that are in your production environment or even in your test environment that are feeding back information to your operations department. Now you're able to possibly capture that data and bring that into your QA and into your test cycles, so that you're actually getting some real-time monitoring, real-time feedback on that. And that becomes especially important for the performance testing aspect. But as we move on and we start to look at, what this environment looks like. So, I'm not going to go through, this isn't a process. This is really just a simplified version of what does it take to, and what interactions between these different tools do we have, and how are they working together, and can you see how all of this can be tied together, whether you have enterprise level tools like ALM and UFT and Lean FT that you're paying lots of money for, or is it open source type of tools like Selenium or Water or Cucumber or other tools that are out there that are continuing to grow in the market and becoming more and more important. So as we step through this, we'll look. You'll see how this, the diagram will flow through and show you just kind of the interaction between all of the parts and pieces in the environment. So when we talk about how does this continuous testing work, your developer, from their IDE is going to do a code check into source code management, whatever flavor it is that you're using. That source code manager is going to, trigger that code check-in is going to trigger something in Jenkins or Hudson in your build servers to actually deploy your test environment or your environment server, and that's going to create that build and push it out to the test server, prod, dev, whatever it is. Here we're focusing on the test server, and once that build is complete, you could have inside of Jenkins or Hudson that connection into ALM that says, hey, I want to run these test sets, and so please kick this off for me. So that CI server is going to trigger ALM in the test lab or in the lab management module or lab management project, basically to look at what tests we have in here, whether they're Lean FT, UFT tests. There's an ability for Lean FT and UFT to kick off Selenium tests, so you could actually have even a further kind of robustness as far as tie into some of these tools, but utilizing the HP tools as kind of as a catalyst to get them started. But now you're going to see it ties into ALM, and picks out that test set. Maybe this first iteration is a unit test. You've got some API tests, and you have some stuff built out in Lean FT. You've got some GUI tests in UFT that you want to execute. Maybe there's some API testing that you've built into UFT too. So you want to run these unit tests, and it kicks it off and it runs it. And the nice part about this integration is all of these tests being so tightly integrated with ALM means that all of the reporting capabilities that you get in ALM come back to you as a benefit. So all of these tests all the run results, all of the the instances that are happening, all of that reporting features as far as being able to automatically generate emails on test failures and anything like that is all going to come in and is available because of that integration with ALM. Additionally, after that, you could have in this same thing, you could have some other unit tests being done in Selenium, calling a Selenium a grid hub, and telling it, hey, we've got a bunch of different browsers, different operating systems that we want to run with. So, fire up these 2 or 3 or 4 Selenium hosts and execute these scripts for us, and Jenkins or Hudson will push that out to them. And kind of the last part of this is there's all these other testing tools that have add-ins to Jenkins or Hudson. We've just listed a couple: Cucumber, Water, Test Complete, Autoit. They all have add-ins. They're able to connect back into Jenkins and Hudson, and let that build server, automation server, tell them to run the specific scripts or tests. Obviously there's some setup and configuration that needs to be done, but you're looking at a whole, like I said, the environment aspect of it. And what we look at here on to the left-hand side is obviously with ALM, we get back to the developers, and I mentioned some of that reporting. This stuff becomes cyclical when we look at this. So we're not saying in this diagram, the process. So like I said, the second iteration of this could be, your developers got some information from ALM. They fix that code, the defects that have been found. They do another code check-in, and now maybe our build server, instead of running a unit test, is going to run a regression. Or maybe it runs that unit test again, validates that those things have been fixed, and then the second step of that is to run a regression build that we have. And then whatever errors are found, we get that back to our developers, and this thing goes on and on as these as the continuous testing kind of, lays out in the way that it's supposed to work.
So,
Hey,
Jimmy,
before, go ahead, Dean.
I just want to interject one thing here, Brent. Sorry about that, but one thing that we like seeing as an HP partner is HP opening the doors to other tools like Selenium and all the open source tools, and they've done, that's kind of been a change from the last few years, and it's nice for us because we work with many customers who have many open source tools. And now that ALM plays well with them, it's so much easier to interact and help them get their environment set up. And now with the up and coming next generation ALM, those doors are open even more. There's much more embedded integration with many tools, open source tools now on the market, and even non-open source tools, competitors' tools that are on the market. So it's just nice to see HP kind of opening up and allowing other tools to play together with them.
Yeah, Dean, I agree, and it's something that I think that we don't forget. But I think when you focus on the tool itself, the tight integrations that it has with other HP tools, it's kind of easy to forget that some of these other open source tools are now available and are able to be worked with in a lot more of a streamlined fashion. When we talk about some of these third-party tools and open source tools, there has been integration with ALM because ALM has an open API where you can kind of set that up, but it's always been kind of a manual process and a lot of code customization, where you're depending upon either you doing it internally or trying to find a third party that might have written some of that so that you have a better integration with ALM. So that next gen coming out and having that as kind of built-in features, to be able to tie into all of these different tools that have become more and more prevalent in the market. I think anybody that that looks at GUI automation or web testing in general understands that how big of a force Selenium has become in the last few years, and especially into the mobile type of market. So I think that there's a lot of that that's happening, and I do agree with you that it's nice to see a little bit more of an open platform for that integration with other tools.
Yeah, absolutely. Thanks, guys. I just wanted to interject real quick while we were on this diagram, a question that came through. Jimmy, I'll hand it to you, and Dean, if you have anything to add to it. But the question was, does the test environment server include the test databases and application servers and everything?
Well, yes. This is a very simple document. Obviously we could expand this out more and have other other arrows that might go to a database server when this build is being deployed. But we tried to keep it fairly straightforward and simple. But when in this diagram, at least with the test environment server, it was meant to represent everything. So all the application is deployed. If there's a database that needs to be deployed with it, all of that would be part of the build, the build job that is ran by Jenkins itself.
Great, thanks so much, Jimmy.
So when we look at this, and we start to look at this environment and how it all works, and we start to think of, well, what are the benefits? What happens if we start to do the we take on this continuous testing and set our environment up for that. And so if we go on to what the benefits are, we start looking at the earlier that we are exposed as testers to the application risks, the better it is. The cheaper it is to fix defects, the more we are able to mitigate that risk going forward in development by either looking at what those risk factors are. Is it a security risk? Is it just some code risks that that we're having trouble with the GUI or user interface type of complaints from the end user. But the earlier we're exposed to that, the better. And of course, along with that is, because of the early exposure, the reduction of time and effort to finding and fixing defects. And this is a pretty common maybe not a slide, but obviously concept in any type of testing. There's always been the old slide or old, adage that, it's 400 times cheaper to find a bug in development and testing than it is if it gets released into the wild, in production. So that's kind of that old adage has always been there. The overall goal of this is to increase the speed and the quality of the delivered software. By testing early, by automating these pieces of it, taking that manual steps out, taking those constraints out that Dean spoke about earlier, allows us to accelerate that development process and allows us to, obviously accelerate our testing. And then those iterative processes, allow that small pieces of improvement. I take a martial arts class that, where our instructor always says, 1%. That's all you're going for. Is if you improve 1% a day, you're always improving. And with an iterative process like that, we might hope for more. But as long as our process is improving and we're continue to, to analyze that and assess that, things are going to get better. Things are going to get more stable. You're going to have more a better product at the end of, at the end of each of those types of iterations. The quality efforts are aligned with the business expectations, and we see that in a traditional waterfall method. It can be months and possibly years. If you have a very complex application between really significant releases, and it can be a complete breakdown between what the business truly needs and what and what you're testing. So, an example I always talk about when we think about it is you look at organizations and how slow they are to adopt possibly, like new operating systems or even Microsoft Office. I can't tell you how many clients I go to that are on Microsoft, Office 2010 or even 2007 type of thing, and it's not because they don't want to move forward, but they might have applications that are dependent upon that version, and they can't move forward until they get a new version of software that's been adapted to the new versions of Microsoft Office or their operating system. Additionally, the ability to focus effort on the quality tests that have the most impact, and that is, it comes back to the same thing. When you're identifying those high risks, those critical bugs, those those things that you want to test. Now, because we're identifying them earlier, we have that iterative process. We can start to weed out those things that are a little bit less critical or that aren't going to have the impact that we would want or that we would expect, and start to focus on those things that are really going to give us the most bang for the buck. And then last but not least, I think the metrics that are included help you not only look at what the state of the software, but also the process, so that as as these iterations go by, that we're improving that. And so, here's a summary, and I think, Dean, you were going to summarize up kind of what we were talking about.
I'll grab this, Jimmy, and give you a break. Thanks. So, kind of in summary, again, the market demands and dictates faster, more automated approach to the software developing lifecycle. We talked about our competitors and our customers, how impatient they are. If you're not moving things faster, you're falling behind. If you're not improving, you're falling behind. Standing still, doing the same thing over and over again, you've heard what that's called, right? That's called insanity, doing the same thing over again, expecting different results. If you're not changing your processes, you're staying the same, and you're going to get the same results. So moving to DevOps, it can start with what we just talked about, CI and CT. You don't have to implement the entire monster all in one failed swoop. Now, we're working with a couple organizations now that are implementing CI and CT, and it can be a kind of a daunting task, really, because there's a lot of changes that need to be made in the organizations to get to this point. Now, for those of you who are utilizing waterfall approach, if you have even a strong automation test suite in place, that is a good start. That's something that can be leveraged in this new environment. So if you're not even there yet, certainly start with bringing automation in place and developing a strong automation framework for API testing and GUI testing and performance testing. Get that in place, and when your organization moves to CI and CT, you can take that right along with you and build on it and leverage it. All right. So it will require some change in roles. It will require some new skill sets. And that's kind of what scares some people is, okay, is my job still going to be here if we change from waterfall to continuous integration, continuous testing? Well, yes, it'll still be there. Your role may change. There may be some education required, things like that. But the tools may change as well. Like we talked about, there are a number of tools you may currently be using in-house that can be leveraged for this new for the new testing environment for CI/CD. Some of them may need to be changed out. They may have some old school tools. Certainly, some old school processes will have to change. That's without a doubt. But take a look at your tool set. Take a look at what's out there in the marketplace to utilize, whether they're pay-for tools or open source tools, and see what best works in your organization. And then education will be required as well. So what new roles will be required for this new environment? What skill sets do we need? Maybe need to bring in new folks who have experience with CI and CT to help your organization get up and running and kind of lead that effort. You may need to bring that person may be an employee, may be a third-party organization coming in and supplying some resources for that effort. But be open to all these items to bring about CI into your organization. And with that, I'll hand it back to you, Brent, for any questions we may have.
Thank you, Dean. We got quite a few questions. We'll take a few before we wrap up because we want to be respectful of everybody's time. Dean, I'm going to throw this first question over to you, if you don't mind. It's how does this work in an agile environment versus a waterfall delivery environment?
Okay, so yeah, a good question. We had a number of that we saw that we're still using agile waterfall for their processes. If you're agile, you're much closer to this mentality of a cyclical environment for your software developing lifecycle as opposed to a linear methodology. So if you are in waterfall, you have a little ways to go, to be honest with you. Like I said just previously, if you have a strong automation process and methodology in place, you're better off. If you're still manual testing, you got probably a couple years to go incrementally to get to the point where you're utilizing continuous testing and continuous integration. So do some research. Be the evangelist in your office that here's where we are, here's what it's costing us, here's the value to get where we want to be, and do some research and find out what could the steps be to get there and the value behind that. So yeah, great question.
Yeah, and Dean, I wanted to piggyback off that just a little bit when you talked about automation. The one thing to remember about this, like we talked about, was that you don't have to implement the whole piece or the whole process to get some benefit of it. So whether you shift left a little bit in your testing methodology, even in a waterfall, development, or whether it's making your automation a little more robust, and that is if you have the ALM license, starting in with some of that the server side type of testing with UFT and lean FT, and that you can start to schedule some of those tests and have them be repeatable, even if they're not maybe tied into a build server or those things. But you can really start to get that a little bit of a feel for that, and that these tests are going to run every Friday and Saturday night, or every after every build. Maybe even if you get manually told the build is done, you just hit the schedule and those tests start to run. So that automation and understanding that and building out the right automation framework can really be that stepping stone to getting into the continuous integration and continuous testing.
Exactly.
So great, thank you, guys. Jimmy, since you were just kind of going, I'm going to throw the next question over to you. It's who builds and maintains the CT environment?
So, obviously every organization is a little different. But one of the things that we talked about was, this breaking down of barriers and silos. So, a lot of these tools are going to be, already assigned or already a part of certain departments in your organization. Your build servers and all of that might be part of development, or you might have a specific team that's out there, that's going to maintain, possibly the server parts of it as far as build server. Now, obviously, the tie-ins to ALM and those things are going to have to be, would be handled by your QA. So it could be, a combination of different roles. You might not just have one person or one small team that does this, but that all depends on the organization and how they want to handle it. Obviously, larger organizations that have more of a process in place already for their builds and who's maintaining, these different pieces of the environment are going to be kind of ahead of the game, because you might have to have a little access given to somebody to set up an add-in or a tie-in to a specific tool, but all of that's going to be in place already. One of the other things is obviously the difference is an on-prem versus a cloud solution. Some of this stuff can be handled in the cloud, where it might be a department, even the QA department would get a login to CloudBees or into a Git or GitHub online type of solution or cloud solution, and it might not be where there's as much maintenance as far as the actual server. It might just be more like the operation and getting the tie-ins to the other tools. So there's a variety of methods. On-prem stuff would be handled a little bit differently than that, and a lot of organizations are already going to have people in place to do that.
Great. Just real quick before I ask the next question, we've had a couple of questions come in asking, maybe they were latecomers asking about if this was being recorded. Just as a reminder, this is being recorded. Everybody will receive a copy of this via email tomorrow with a link to that recording. So with that said, next question, I'm going to go over to Dean again. Dean, how do we track defects in this process?
All right, so a lot of that will come down to the tools that you're using. There are a number of defect tracking tools on the market. Again, there are a number of open source tools, but whatever tool you're using, make sure it is integrated with your testing efforts. So in the case of ALM, you would trigger these test runs from ALM, and then you can actually build or create a defect when a failure is detected, whether in an automated environment or testing manually. So the metrics from those defects, or the defects themselves, should be associated with that test, all right? And in turn, that test can be associated with a requirement, and then reporting can be actually done on the requirement level as far as what requirements passed or failed based on the test execution. And then as far as going back to the defects, is making sure your developers have access to those defects in that same tool as well, and they're receiving automated emails possibly, or internal notifications via that tool that a defect has been assigned to them, and then there should be a defect life cycle that your organization has defined on who can change that life cycle from what status to another status. So again, it kind of goes back to what tool you're using. They support different areas of those things I just mentioned.
Yeah, Dean, and I wanted to, I was going to add a couple of things. We talked about synchronization as far as from the continuous testing side, but when you talk about the reporting part of it, ALM, and especially like now in 12.5 and going forward in the next gen, that synchronization and integration, works between Jira and Bugzilla and some of those other defect and requirements, management tools also. So you certainly can use ALM as a central hub and still allow your development teams to, if they're interacting with Jira in general, or anything like that, when you've got bugs found, that synchronization can come, both ways, bidirectionally. You enter it in Jira or you enter it in ALM, and it will populate in Jira also. So there's, some of that stuff will come back to just how and what tools, like you said, are available in their environment.
Great. Thank you guys so much. So we're coming right up on the hour. So we have a few other questions, but like I said, we will reach out to you with the answers to those questions in the coming week or so. But I did want to go ahead and wrap things up. So before we close out today, I just want to talk about some of the upcoming Checkpoint Technologies events. Next week, we'll be in booth number 4 at the QAI Quest conference, which is in Chicago. So come out and see us if you're attending. Right after that, we'll be at the Star East conference, which is in Orlando, Florida, and we'll be in booth 20, which is May 1st through the 6th. And then on May 25th, we have our next webinar. It's titled Automating Your Mobile Testing with Mobile Labs, UFT, and Selenium. So for registration or more information on any of our upcoming events, just visit our events page on our website, which is checkpointtech.com. I want to invite the audience to reach out to either one of our presenters today with any questions you may have on this webinar topic or anything your organization may need assistance with. I also do encourage everyone here to take the very short survey at the end of this webinar, letting us know how we did and whether you'd like us to contact you within the next few days. So with that, on behalf of myself, Jim Parsons, Dean Carvin, and everyone here at Checkpoint Technologies, we hope you enjoyed our webinar, and we hope you have a great rest of your day.
Thanks, guys.
Well.